Hey there, if you're a developer, you definitely know this feeling. You push one tiny change, and then you just sit there and wait for your Docker image to build. Well, today, we are going to fix that. We're going to dive deep into Docker caching and show you how to make your builds way faster and your images way smaller. So this whole thing kicks off with a story. A developer over on Reddit posted this exact error message. Their CI pipeline was failing, not because of bad code, but because their Docker image had gotten so bloated that it was literally too big to even upload to the registry. It's that kind of problem that just sneaks up on you, one build at a time.
So yeah, that's the big question, right? Your build is taking forever, your final image is massive. How do you get things back under control? That is exactly what we are going to break down right now.
All right, to fix any of this, you have to get one thing straight, and that is layers. Understanding this one core concept is absolutely essential, because pretty much everything about Docker optimization comes back to this one idea.
Think of it like this. Every single line in your Dockerfile, your from, your run, your copy, it creates a layer, kind of like a transparent sheet of plastic. Docker then stacks all these sheets on top of each other to create your final image. And here's where the magic comes in. When you rebuild, if a sheet hasn't changed, Docker doesn't bother recreating it. It just grabs the old one from its cache. And that is the secret to blazing fast builds. Let's make this super practical. First, the from instruction lays down our base layer. Then, we copy our requirements file. Boom, that's a new layer. Then we run pip install, you guessed it, another layer. And finally, we copy all of our application code. Now, here's the really crucial part. If you change your app code, only that last layer gets rebuilt. Easy. But if you change the requirements.txt file, everything after it has to be rebuilt from scratch, the pip install layer and the final copy layer. This chain reaction is everything.
Okay, so now that we get how layers work, let's put that knowledge to work. We can make some seriously high-impact changes right inside our Docker file that will take full advantage of that cache. This right here is probably the single most effective trick you can learn. Seriously, look at the slow way. We copy all our code and then we run npm install. What does that mean? It means every time you change a single line of your code, you have to reinstall all your dependencies all over again. The fast way is so much smarter. First, we copy only the package.json file. Then we install our dependencies, and only after that do we copy the rest of our code. Now that npm install layer gets cached and reused almost every single time. And here are a few more quick wins for you. First, use a dockerignore file. It works exactly like a .gitignore. You just tell Docker to ignore stuff like logs or local build artifacts. This shrinks the amount of stuff Docker has to process, which speeds things up right at the start. Second, chain your commands together with and. This bundles multiple steps into one single layer, which is just more efficient. And finally, if you're installing packages, always clean up the cache in that same run command. Otherwise, all those temporary files get baked into that layer forever, bloating your image.
Okay, let's switch gears and talk about image size. A super common mistake, especially with compiled languages like Go, is the single-stage build. See, you need the Go compiler and all its tools to build your app, but you absolutely do not need that entire heavy toolchain just to run the final binary. And if you leave it all in there, you end up with this massive bloated image. And this is where the solution comes in, and it is brilliant: multi-stage builds. It's basically like having two Docker files in one. The first stage, we'll call it our builder, is like our messy workshop. It's got all the heavy tools, like the Go compiler, and we use it to build our application. Then, we start a completely fresh, squeaky clean second stage, maybe from a tiny base image like Alpine. And we use that copy-from builder command to just pluck the finished product, the single compiled binary, out of the workshop. The entire messy workshop gets left behind.
And what does a strategy like this actually look like in the real world? Well, remember that developer on Reddit I mentioned? They used a multi-stage build for their Python backend, and they shrank their image from a whopping 600 megabytes all the way down to just 250. That's less than half the size, all by just separating the build tools from the final runtime.
So, getting your layer order right and using multi-stage builds, those are the fundamentals. But if you really want to get into the advanced stuff and push for maximum speed and efficiency, we got to talk about Docker's modern build engine, BuildKit. It unlocks some seriously powerful tools. This is an absolute game changer. Normally, when you run npm install, that cache of downloaded packages either gets baked into a layer or just thrown away. But BuildKit's cache mounts let you create a special cache directory that lives outside the image layers, but it sticks around between your builds.
So you can see in the command, we're just telling npm to use this external cache. The result? Insanely faster dependency installs without adding a single byte to your final image. Now, when you're exporting this cache, BuildKit gives you two main modes. Mode equals min is the default. It's simple. It only saves the layers from your final image. It's fast to export, but you lose all the caching from your earlier build stages. For multi-stage builds, mode equals max is where the real power is. It saves all the layers from all the stages. Now, it takes a little longer to export this bigger cache, but it means your next build can reuse all those intermediate steps, which often saves a ton of time.
So far, all this stuff is great for speeding up builds on your own machine. But where things get really powerful is when you share this magic with your entire team and your CI pipeline.
BuildKit lets you store your cache in a bunch of different places, which it calls backends. Sure, you can keep it local, but the real magic is sharing it. You can push your cache up to a Docker registry, just like an image, or use cloud storage like an S3 bucket. And if you're on GitHub Actions, it has its own built-in caching. This means your CI system and every developer on the team can pull from and contribute to the exact same cache.
And here's what that looks like in practice. When you run your build, you just add two flags. -cache2 tells Docker, hey, after you build this, push the new cache layers here. And -cache_from tells it, before you start, pull down any existing cache layers from here. Just like that, everyone on the team and every CI job starts benefiting from each other's builds. It's awesome. Okay, we have gone through a ton of technical tricks, but to wrap this all up, let's zoom out for a second and talk about the core philosophy that should be guiding every one of these decisions. Let's call it the golden rule of containers. This quote from a developer in that same Reddit thread just perfectly captures the goal. A container isn't just a convenient wrapper for your code, it should be a complete, self-sufficient, unchangeable artifact. But what does ready to run actually mean? It means that when you type Docker run, your container just works, instantly. It shouldn't have to reach out to the internet to download dependencies from PyPy or NPM when it starts up. That's a huge anti-pattern. It makes your whole application fragile and slow. By baking everything into the image, you create a versioned, testable artifact that you know is going to be reliable and consistent every single time you run it. So, you've done it. You've optimized your layer order, you've mastered multi-stage builds, you're leveraging a shared cache across your whole team, your builds are fast, your images are tiny, but optimization is never really finished, right? By crushing one bottleneck, all you've really done is reveal the next one. So the question I'll leave you with is this. Now that your builds are fast, what's the next bottleneck you need to break? Thanks for tuning in.